and Will here with our LCD program. Take a look at the program. We defined a couple things. We defined port B as Mr. Crib, port D as our control. You'll see where they're plugged in later on the board. We also define our enable switch, read-write switch, and our busy signal. We do those so we don't have to figure out which one PD is. We know it's the enable switch, kind of program it to make sense. Right here we state a couple functions. This is our main loop right here, and it clears the screen, sends a 2-line 5x7, and through here this is our code. So each character we send individually through the send a character function, and we go down here and look at send a character function. It checks to see if it's busy, make sure the bit's low. We send the character, write a high signal, and then wait for it to happen, and then write a low signal, and that sends each character one by one.
Okay, so what we have here is the LCD. I'll explain more about the pinouts and what each pin is. Pin 1 is starts from here, which is the VSS, the ground, and then pin 2, VDD. Pin 3 is the contrast adjustment, which is V0. And pin 4 is RS, the register select signal. Pin 5 is the read and write, RW. And pin 6 is in the enable. So in 7 through 10, that is the 4 low data lines, and 11 through 14 is the 4 high data lines. And 15 is the anode, 16 is the ground, which is the backlight display.
Yeah, so that's not used in this project, so it's not wired to anything. And this here is the results for Hey Steve here, as you've seen earlier in our program for the hex values for each letter that was sent through to the LCD. And then here on our board here, we have a connections going to our data bus, which is connected to PB0 through PB7. And also our outputs are on, selects are on port D here for enable register select here. And then set our power connected to VCC, and then our ground here. Yep, that's all for this project.